Welcome back, everybody. This is our Unit 4 review for the three-dimensional media and techniques. So we started off with sculpture, and in general, we can divide sculptures into two really broad categories or groupings. Sculptures are either fully three-dimensional, they're either on a pedestal or they can stand on their own, and they can be viewed from 360 degrees. Like if you walked around them in a circle, you could see them from all points of view, and that's the example to the right, the same sculpture seen from multiple points of view. We refer to these as sculpture in the round, but here we see an angled view of a sculpture that essentially has a flat background from which things project forward, and you can see that some areas project very slightly and some project quite a lot. This is what we call a relief. So a relief is a sculpture usually mounted to a wall or part of a vertical standing element as opposed to freestanding in its own right. Within the category of relief, though, we can subdivide a little further and determine whether the relief is extending very far from the background or not very far. So a coin would be a good example of something that has a low relief, like the face of the president on a quarter is not a huge extension in space, much like the example of this horse here. Definitely the face projects forward from the background, but not by a lot. In this example, some elements, the foreground parts, the hooves and legs, extend so far forward you could wrap your hand around them. This would be an example of high relief. So we call low relief bas in French. High relief in French is haute relief. So either term works. In this example, you can see the same subjects being presented in three different formats. So these are sculptural options. This was made as a proposal for probably a public monument, and people were voting on which version they would prefer. So we have fully three-dimensional freestanding figures here in the center. This would be an example of sculpture in the round, flanked by two relief versions. This is low relief, not projecting terribly far. But the image on the left is high relief. Some of those arms and other elements extend so far into space that they definitely not only cast shadows, but you can physically wrap your hand around those as well. We looked at sculpture based on the material that it was made from and the techniques it was made with. So our modeling technique is the first one to look at. When we were thinking about the techniques of making sculpture, we noted whether those techniques were additive or subtractive. So in this case, we're calling this an additive technique. This is the work we do with something like clay or wax, something that's pliable, that's easily manipulated, can be pinched and pulled and stretched, and because it's sticky, bits can be added onto it. So modeling in clay or wax is an additive technique. Carving is your primary subtractive technique, and it's usually stone or wood. We're removing elements from those materials. So sometimes you can tell whether something's carved just by looking at the material it's made from. If a sculpture is made of wood, then most likely it's carved. If you're looking at something that's labeled stone or a type of stone like marble or granite, then you're most likely looking at something that has been carved. Casting is another technique that is basically a category unto itself. With casting, we looked at making an original image, usually in clay, and then making a plaster mold of that. Taking the mold off of that original object, putting the two halves of the mold back together so it's hollow on the inside, coating the inside of that mold with wax, and then filling the wax with plaster, removing the mold again, would create a wax replica with a plaster core. We would then put pins through the wax into the plaster in the core and add what we call sprues, S-P-R-U-E-S, to facilitate the flow of metal in our final version. We would then pour a plaster mold around all of that, and then place the whole thing in a kiln, which would cause the wax to melt out, leaving empty channels where the sprues were, and holding the core in place because of the pins. Then we would heat the metal up until it becomes liquid, put it in a crucible, and literally pour it into the opening in the mold. Therefore, the metal would replace all of where the wax had been. And once it's cooled, we would smash the mold off, and you'd have an object like this. So you would have to then cut off the metal that had filled where the sprues were, as well as the pins themselves, in a process called chasing. The assemblage technique of making sculpture is also additive. And with assemblage or assemblage, we're usually putting things together. And those things could be things that already exist in the real world, and we refer to those as found objects. So a lot of different techniques could be used here. You might use nails or screws or bolts. You might use an epoxy or a glue of some kind. There's all kinds of different ways of attaching elements together. But this would be the work of an additive technique known as assemblage. Within assemblage, there are some artists specifically coming to us from the Dada tradition who really pioneered the idea of using objects that already existed. They're found object creations ready-made, because it was like they were already made. They just took something from the real world, called it a sculpture, boom, there you go. One sculptor I do want you to know is definitely Andy Goldsworthy. We looked at some of his work in the sculpture section, and his work is generally classified as earthworks. You could call these assemblage sculptures. They are objects put together, and they're objects that already exist. With Andy Goldsworthy, the key, though, is that he uses all natural materials that he finds in the real world, in the natural environment, and he doesn't use permanent ways of fixing things together. He's not creating metal armatures or welding things together. Normally, he puts the objects together and then allows them to be reclaimed by nature through wind and rain and other erosion effects. So they're temporary. They're meant to exist without harming the planet itself. When we looked at architecture, we talked about two big categories for structures. Either the shell system, which is pretty basic. The shell system is kind of like a turtle shell. The exterior surface is also the thing that's supporting all the weight of the upper levels and the roof. So something like an igloo or something like a traditional log cabin would be a good example of a shell structure. Shell structures, of course, are doing the job of carrying the weight of the upper levels. The walls themselves are load-bearing. They're what's carrying the weight. In a skeleton and skin system, what is carrying the weight, what is load-bearing, interior skeleton, either a wooden or, in the case of a skyscraper, a steel frame skeleton that can then be faced with whatever other material we want, whether that be wood or siding or glass or metal or whatever we decide we want to use. We also want to know the term tensile strength when we're talking about architecture. Tensile strength is the ability of a material to span a horizontal space without any support from below. So the space of an opening, like a doorway or a window, the upper level, the lintel in a doorway, has to have tensile strength to be sufficient to span that much space without needing a support in the middle. Post and lintel architecture has been with us for centuries. The post is the vertical element, the lintel is the horizontal piece, and it creates this kind of doorway effect. Again, here's a post and lintel with a little more refined architectural style, post and lintel. From the post and lintel, we developed this idea of spanning a horizontal space with architectural element above. And so the Romans actually extend this idea. Instead of just using a flat surface, they realized that they could create a taller height between these two posts by placing a half circular arch. And so this rounded arch is made of stone sections. These stones are known as the voussoirs, and they're shaped like wedges. But the wedge-shaped, the big one at the top, is called the keystone, and it's the one that, once it's in place, it exerts pressure on all the others and holds the whole thing together. So here's how an arch is built. We create a wooden truss first and then start laying the individual voussoirs, and then once the keystone is placed, that wooden structure can be removed. We also looked from the Greek era into Rome, into the Middle Ages, into our own architecture today, the use of these, what we call classical orders. They come to us from ancient Greece. They are the evolution of the structural styles of architectural decoration. And the earliest simple style is called the Doric. The classical era style is the Ionic, and the end of the classical era of ancient Greece under Alexander the Great is the Corinthian style. You can tell these styles apart when you look at their capitals. The top of the column is the key thing to look for. So looking at the diagrams, now looking at actual ruins from ancient Greece, this is a Doric capital, a simple drum. The Ionic capital has curlicues on it, or volutes, V-O-L-U-T-E-S. And the Corinthian style is this elaborate carved element that looks like abstract leaves. These are meant to look like acanthus leaves. You can see the Romans using these styles. The Greeks would never have put all of these together on one building, but you can see here at the Roman Colosseum, Doric columns on the first level, Ionic columns on the second level, and Corinthian columns here on the third level. Technically, these are engaged columns. They're half round. They're physically attached to the wall. They're not actually structural. They're purely decorative in this case. There are 80 arches on each level around the original design of the Colosseum. So 240 of these decorative openings all the way around that structure. The volutes, again, are the curlicues on the Ionic order. They're on the corners of that capital. Another Roman innovation, in addition to the rounded arch, is the use of concrete. And believe it or not, the Romans actually made enormous structures by building wooden molds and then pouring concrete into them once the concrete was hardened, removing the wood, and then putting decorative panels of marble on the front of the concrete. So it required much less stone, and it also made it possible to build a really huge dome. This is the Colosseum. So if you think about the architecture of a round arch, if you took an arch and spun it 360 degrees, you would create this hemispherical dome. As we moved out of the Roman era and into the Christian era, we developed this Roman sense of architecture a little further. So the Roman round arch becomes the basis for our early Middle Ages architecture in Western Europe. We call this the Romanesque style because of the round arches. But eventually, architects decided that they wanted to build even taller and taller churches, and to do that, instead of a round arch, they utilized this pointed arch. And that was for two reasons. The pointed arch would be very much more likely to allow you to create a tall ceiling or a tall roof line, because a round arch would have to have its two supports set further and further apart if you were going taller and taller and taller. But also round arches push out a lot of pressure to their sides, whereas pointed arches push more pressure downward. And so it's a much more practical way of building tall if you're going to go with a pointed arch. So the pointed arch style is called Gothic. That's the second era of the Middle Ages. The next big innovation after the pointed arch is the advent of cast iron and making things in prefabricated units. So we see that with the Crystal Palace, in which the elements of this building were made in a factory, shipped to the site, and assembled. So this building was built very, very quickly by using repeatable pre-made or prefabricated units cast in molds in iron. But iron has limitations. It's heavy and it is kind of brittle. So we move from iron to steel, and that allows us to build the very first true skyscrapers. So Louis Sullivan is one of the architects who created this kind of idea in America, and his design philosophy you want to recognize for the purpose of the test. Louis Sullivan is the architect who said that form, follows function. Form is how things look. Follows is coming after function. So the most important first thing is function, how the thing is used, should determine how it looks. The next big design movement that happens because of these materials of steel is the international style of architecture. We call it international because this simple, geometric, and modern idea of modern materials of steel and glass really comes from the Bauhaus in Germany, an art, architecture, and design school that was shut down by the Nazis. And the teachers of the Bauhaus came to America and spread their ideas here. So it became known as international style because European architects and American architects were promoting this idea around the world. So this is the Bauhaus curriculum plan. This is the work of design of the second director of the Bauhaus working in New York City in America, Ludwig Mies van der Rohe. And I want you to know van der Rohe's design philosophy, very easy to remember, less is more. The teachers of the Bauhaus, many of them did actually teach in other places in America, including at Black Mountain College in Asheville. And so some of these design ideas about the unity of all the arts of dance and sculpture and fashion and architecture all came together in America at the Bauhaus right here in North Carolina. The architect we wanted to know for the test is a very unique individualist, an architect who doesn't really imitate anyone else's style. This is Frank Lloyd Wright, and he is best known to us for this prairie style, these long horizontal buildings that he created in the early 20th century. We talked about design and the importance of things at different price points. We talked about utilitarian, simply functional, being different from objects that have an aesthetic, beautiful quality as well. So when we looked at the crafts, we were thinking about utilitarian use objects, but objects of beauty, objects that have an aesthetic quality. We talked about the fine crafts, capital F, capital C. So ceramicists making beautiful objects are using clay to do that. And there's three main types of clay to know. You don't have to know the actual temperatures. You can just know medium, low, and high. But clay changes when it's exposed to different when it's exposed to extreme heat. It literally changes from a material that is plastic, flexible, plastic meaning pliable or moldable. When it is exposed to extreme heat, clay becomes completely rigid, and it cannot be reverted back to that plastic state. And the temperatures required to do that are really much higher than your oven temperature at home. So I don't want you to know the numbers, just know low, medium, and high. The coarse clay is earthenware. It is reddish brown, and it has the lowest firing temperature. Stoneware is the gray clay. It has the medium firing temperature. The finest clay, the clay that has smallest clay particles, is porcelain. It's whitish in color, and it requires the highest firing temperature. Before you can work with the clay, you have to wedge it, which is an act of kneading the clay to remove the air bubbles. And we looked at simple ways of making clay objects. The pinch pot is essentially taking a ball of clay, sticking your thumb into it, and then pinching the wall to create a bowl shape or a vase shape. The coil technique involves rolling the clay out into snakes or coils and then basically stacking those coils one on top of the other to form the walls of the pot. But those walls have to be solidified by blending one piece of clay into the piece below it in a technique we call weld. So you can see here the thumb is being used to weld the coil that's just been put on the top into the area below it. And so you could weld a coil pot both on the inside and outside, which this artist has done, or you could just weld it on the inside, which would leave this beautiful pattern on the outside. Slab construction is the technique of taking the clay and extruding it into flat pieces, cutting and shaping them into panels of whatever shape you want, and then using a technique known as score and slip joining to put them together. You can see here there's some kind of scratch marks, and you can see this goopy material here. That's the scoring, kind of cross-hatching that we do with a needle tool. The slip is just clay with a lot of water in it, and it acts kind of like a glue. So we do score marks on all the sides that are going to touch. We put the slip on there, attach the pieces together, and then if you want to, you can even weld a coil into the seam just to make it stronger. So here's the score being made. You can see the slip there. That's the score and slip joining. Of course, you're familiar with throwing pots on the potter's wheel. Essentially, you're taking clay, centering it on the wheel, which is spinning around, opening it up with your fingers, pinching it and stretching it until you begin to change its shape. We have either kick wheels, traditional, or the electric wheels that allow you to control the speed at which that working surface is spinning. So you can kind of tell from this slide what techniques the objects were made with. This has flat planes. This is a slab pot. This is a little irregular. That's a pinch pot. You can still see the pattern in this. That's a coil pot. And here's a wheel thrown pot. The techniques for fine crafts with glass, the main thing to remember is that we've had the technology of the glass blowing pipe since ancient Rome. So remember, not only do you want to know the Romans for the round arch and for concrete and the dome, but also blown glass. The most famous blown glass artist we looked at from the 20th, 21st century, of course, is Dale Chihuly. So you want to recognize his name for the test. We also looked at the fiber arts. We looked at taking either plant or animal fibers, hair or plant fibers, spinning those fibers together to make thread, and then threading a loom to create weaving, to weave cloth. When we're weaving, the threads that are held tight are known as the warp threads. The threads that we weave in and out to create the pattern of the fabric are known as the weft threads. So warp are the ones that are taut. Once you've woven a cloth, you could embellish it with embroidery, stitching a design onto it. So we looked at the Bayeux tapestry. Even though we call it a tapestry, it is actually an embroidery. The design is stitched onto the surface. True embroidery is usually made with an A-frame loom like these, and is essentially making the weaving and the design simultaneously. You're making the picture by changing the color of the thread that you're weaving in and out of the warp to make the design. Quilting is the technique of taking pieces of cloth, stitching them together, and then making a three-layered element. You have the top that you've pieced together, you have the batting, the cotton stuff in the middle, and then you have a backing sheet. And all of that is quilted together by stitching all through those three layers to make those little air pockets to make a quilt retain heat. We also looked at metal smithing. We looked at different techniques with metal. The most recognizable one you see here is forging, heating metal in a forge and then hammering it on an anvil to change its shape. We also have the technique of repoussé, working metal from the back to raise a design on the front, filigree, the braiding technique, and cloisonné, the technique of enameling. We looked at wood crafts as well. We looked at them primarily as being carved and used for furniture and ceremonial objects. Then we looked at specific designers. I want you to recognize the designer's name and the technique or the style they're best known for. William Morris is the designer best known for the arts and crafts movement. They espoused the idea of handmade objects as opposed to machine-made objects during the Industrial Revolution. We looked at the Art Nouveau movement, the art of Louis Comfort Tiffany in glass. The Art Nouveau artists emphasized natural, organic forms, and Tiffany is best known for his febrile or iridescent glass. He actually patented his formula for febrile glass in 1894. We then looked at the art style of Art Deco, roughly the 1920s now. The style is very much about geometric shapes, usually a lot of silver and black, and I wanted you to recognize the work of the designer Paul Frankel, best known for his skyscraper furniture. We also looked in the 20s at a European design style that was influential, known as de stijl, which translates to English as the style. It was a attempt to create a universal style that was not dependent on culture or nationality or even money. It was open floor plan, geometric shapes, and simple use of primary colors in black and white. This comes to us from Holland. The designer to know is Gerrit Rietveld. We also looked, of course, at the Bauhaus, not only at the architecture that became the international style, but at the furniture design. Marcel Breuer is the designer of the Breuer chair to recognize for the test. So Breuer, Bauhaus, that's pretty easy. We also looked at the introduction of organic shape back into design in the 40s through the designers Eames and Saarinen. And we ended our discussion of design, both of architecture and of industrial design objects, with this discussion of the idea of postmodern. The term itself is not great. Post just means after. So we're looking at sculpture, architecture, artwork, design, fine craft objects from after the modern era. We generally refer to modern art as the art of the early 20th century till about the 1960s, give or take. So you have been living during the postmodern era, and one of the ideas of postmodernism is being able to mix and match and combine unexpected things, what we sometimes call the multiplicity of style. So that's at the heart of postmodernism.